All right, so this is a sort of a typical trig problem. You're going to be given some information, right? Sine of alpha is 3/5, and then they tell you that alpha is in quadrant 1, sine of beta is 5/13, beta is in quadrant 2, and for the first part here, we're supposed to find the cosine of alpha plus beta. All right, so the first thing that I want you to do when you have these types of problems is draw the two separate pictures, okay, in the appropriate quadrants. So what I mean by that is let's take all the information from part 1 here, and we're going to do sine alpha is 3/5 and alpha is in quadrant number 1. So we're going to draw, this is going to be my alpha picture, okay? This is the alpha picture. And what I know about the alpha picture is that it's in quadrant number 1. So here's alpha, here's quadrant number 1, okay? I have some angle in here that they're calling alpha, and what do I know about that angle? What do I know about it? I know something about it. I've been given some information. What do they tell me? Its sine is 3/5. So where does the 3 have to go? The opposite side. Very good. Where does the 5 have to go? Good. So what does that make this part down here? A 4. It's a 3, 4, 5 triangle, right? That one was given to us. That's pretty straightforward. So there's the alpha picture. Now I want to draw the beta picture. What quadrant is beta in? What does this one tell us? It's in quadrant number 2, right? So I'm going to highlight a picture. This is going to be my beta picture, and it's highlighted in quadrant number 2. All right, and I'm going to draw my right triangle, and I'm going to draw, there's beta. All right, what do I know about beta? I've been given some information. What did it tell me? What did it tell me about its sine? Its sine is 5/13, right? So the 5 has to go here. That means the 13 has to go there. So, ladies and gentlemen, what goes right there? What is that side? How do we get it? Yeah, 12, right? How do you know that? What do you guys do? Pythagorean theorem, right? Very good. So you just say x squared plus 5 squared has to be 13 squared, so blah, 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 x is equal to 12, okay? But since I'm in quadrant number 2, it has to be a negative 12. Very good. So this has to be a value of negative 12, all right? So there's all the information that I'm given. The first thing I want you to do is draw that picture to represent all that information. So far, so good? Feeling good? All right, now I want the cosine of alpha plus beta. So cosine of alpha plus beta. Well, according to our formula for the sum formulas, it's going to be the cosine of alpha times the cosine of beta plus or minus. Minus the sine of alpha times the sine of beta. So looking at the alpha picture, what's the cosine of alpha? Looking over here, the alpha picture, what's the cosine? The cosine is the, yeah. What's the definition of cosine again, you guys? Adjacent to the hypotenuse. Good. So cosine's 4/5. What? Now look at the beta picture. What's the cosine of beta? Negative 12/13. Very good. Okay. Minus, what's the sine of alpha? Look at the alpha picture. Yeah, we were given that one, 3/5, right? And then what's the sine of beta? Look at the beta picture. 5/13. Very good. So all we need to do is compute this information. So 4 times negative 12, I got negative 48. All over 5/13 is 65. And then I have a minus sign, and then I have 3 times 5 is 15, all over 65. So combining everything like terms, I'm getting negative 63/65. So that represents the cosine, the double or the sum of alpha plus beta. So table groups, figure out sine alpha plus beta given the same information that we were given up above. All this stuff, figure out sine alpha plus beta. All right, so do you guys come up with negative 16/65? Yeah? Okay, you feeling pretty good about sine and cosine for sum and difference? Yes? Yeah, all right, we're gonna move on to tangent now, right? So second idea here. All right, so these should already be in your toolkit, all right, because you did them the other day for homework. And I want to just point out a couple of similarities here. First of all, tangent is a fraction, right? So it's easy to represent tangent as like sine over cosine. So we remember it's a fraction, so there's gonna be two parts, top and a bottom. Whatever sign is inside the parentheses here, the sum is gonna match on the top there. So those are gonna match, okay? So notice the negative sign there and the negative sign there. Those are going to match. And then it will always be opposite down below, whichever one is opposite. Everything else is pretty much stays the same. So there's something that might help you sort of, get familiar with the formula, all right? It is in the toolkit, but I want to at least point it out to you. So our focus for today is me working with this particular identity. Are you guys cool with this part so far? All right, so let's practice some of these. Here's the third idea. Whoops, give me a pen. Okay. All right, here's the setup, everybody. So you're given the sine of alpha is 4/5. Alpha's in quadrant 1. The cosine of beta is negative 12/13. Beta is in quadrant 2. What is the tangent of alpha plus beta? Okay, same strategy as before. What's the first thing we're going to do, everybody? We're going to draw a picture. That's right. So I'm going to draw my alpha picture, and I'm going to highlight quadrant number 1. So here's my alpha picture, and it's in quadrant number 1. Okay, so I'm going to draw a right triangle in the appropriate spot. This is going to be my alpha. And what do I know about alpha? I've been given some information. Its sine is equal to what? 4/5. So where does the 4 have to go? Sine is opposite over hypotenuse, so 4/5. What does that make the other side? 3. These are pretty easy so far, giving you some nice easy numbers to work with. They won't always be that way. Yeah, you got it. Cosine beta is negative 12/13, so we're going to be in quadrant number 2. So here's quadrant number 2. Here's our beta. Here's quadrant number 2. Okay, I'm going to draw the appropriate right triangle. I'm going to draw my picture. And this is my angle beta. And I've been given some information about beta. I know the cosine is what? Negative 12/13 in that ratio. So what's the definition of cosine again? Shout it out real quick. Adjacent over hypotenuse. So the 12 has to be the adjacent. So negative 12/13. What does that make this missing side here? Anybody know? 5, yeah, very good. Do some Pythagorean theorem and you get a 5 right there. All right, and it's positive because it's up, right? So the y value is positive for that case. So I have all the appropriate information drawn. It's really helpful to draw the picture. No, 4/5, sorry. So here you go. Let's do some computation then. The tangent of, we're going alpha plus beta, is supposed to be tangent of alpha plus the tangent of beta, all divided by 1 minus tan alpha tan beta. All right, so let's take it nice and slow because we don't want to mess with this part up here. Tangent of alpha, let's look at the alpha picture. Okay, what is the value for the tangent of alpha? 4/3, very good. Yeah, opposite over adjacent. So I got 4/3 plus, let's look at the beta picture. What is the tangent of beta? Negative 5/12. Very good. Negative 5/12. Good. On the denominator, I've got a 1 minus the product of those two numbers. So I'm going to have a 4/3 and a negative 5/12 because that's the formula says, the product of those two numbers together, right? I know, it doesn't look that bad, but these can get really confusing in terms of what we do with our fractions, okay? So I've got 4/3. I've got minus 5/12. I have divided by 1 plus 20 over 36. All right. It's a negative times a negative, all right? All right, let's get a common denominator. What's the common denominator for 3 and 12? Maybe 12. So this piece needs a what? This needs a 4/4. Very good. So that's going to give you 16, all right, minus 5 all over the common denominator of 12, divided by, I need to change this 1 into 36 over 36, right, to make a fancy 1 to get a common denominator. So then that would give me 36 plus 20 all over 36. You guys cool with that part? Okay. So therefore, what do I have left? With 16 minus 5, I've got 11 over 12. All divided by 56 over 36. So far, so good? All right. So we're going to flip and multiply. That gives me 11/12 multiplied by 36 over 56. Notice 36 divided by 12 is a value of 3, leaving me with 33/56. So that is the exact answer for the tangent of alpha plus beta, and that's what you do. So looking at the entire problem from start to finish, okay, so the idea is they gave us some information. We then took that information and we drew the appropriate pictures. We filled in the missing gaps. Then we applied the formula and we simplified using our adding fractions and multiplying together. What do you guys think? Easy, medium, or hard? So here's the information. Tangent of alpha is -3/4. Alpha is in quadrant 2. Cosine beta is a third. Beta's in quadrant 1, so I want everyone to go ahead and draw their pictures that represents the situation there and fill in the missing gaps, okay? All right, so are these the pictures that you guys come up with? Yeah, so the missing sides for the alpha picture was the hypotenuse of 5. Notice that -4 is in the right spot because I'm going to the left 4 units and then up 3, so that gives me that tangent value of a -3/4. And then I have my beta picture, so I'm getting the missing side was 2√2, the highlighted one. Is everybody okay with how I got the 2√2? All right, good. So we're going to figure out the tangent of alpha plus beta. That's going to be our goal for this one. So we're going to figure out the tangent of alpha plus beta. Okay, according to our sum formula, that's going to be the tangent of alpha plus the tangent of beta, all divided by 1 minus the tangent of alpha times the tangent of beta. Okay, let's go ahead and fill in the information that we know. What is the tangent of alpha? Let's look at our alpha picture. What would tangent have to be there? -3/4, very good. So I have -3/4, okay? Then I have plus. What's the tangent of beta? Take a look at that picture. What do you get? 2√2, very good. I get that same thing. 2√2 over 1. Okay, then all divided by. Yeah, there's lots of ways you can still compute it, right? You can keep it that way. 1 minus -3/4 times 2√2 over 1. Okay. All right, so let's start our simplification process. This is the hardest part because there's so many ways to make like tiny little errors here. So I got -3/4. I'm going to have plus, let's see here. This piece needs what to get a common denominator? I need a 4 over 4, right? So that's going to give me 4 times 2 rad 2 is going to give me what, 8 rad 2? Yeah. 8 rad 2, all divided by 4. All right, good. And then on the bottom here, let's see here. I'm going to have 1 plus, this is going to be 6√2 all over 4. All right, everybody so far so good? All right, let's keep working with this. In the numerator, I can simplify that to -3 plus 8√2 all divided by 4. True? No problem? That's bringing those together. In my numerator, check it out. I'm going to make this a 4 over 4, right? So that's going to give me 4 plus a 6√2 over a 4. Okay? So check this out. This top part is a fraction. This bottom part is a fraction, right? It is true that if you have a fraction divided by a fraction, all right, and these numbers are the same, they do end up crossing out, leaving you with this piece over that piece when you flip and multiply. Do you guys know that? I mean, it's pretty much the same thing, okay? So if it's okay with you, I'm going to rewrite it in a certain way, and maybe you'll see why I do it. I'm going to rewrite this like this. 8√2 minus 3, all divided by 6√2 plus 4. All right, for me, that makes more sense. It's a little easier to work with. Is everybody cool to this point? Yeah. Questions about how I got here? Okay, now what do I do? This is the hardest part. I can't leave it like that. I have to do something. I have to rationalize the denominator. Yeah, what's that called? It's called the conjugate. Very good. We are going to multiply by the conjugate, right? And the conjugate is 6√2 minus 4 over a 6√2 minus 4. After all, that's a fancy one. We're allowed to do that. We're not making any mistakes by changing the value of our quantity, right? Okay, so let's do this together here. We're going to do FOIL. All right, first, outer, and last. So what's 8√2 times 6√2? 48. That's going to be 48 times 2, which is? 96. Very good. That's my first. Let's do outer. It's going to give me -4 times 8. How much is that? That's going to be -32√2. Okay? Let's do inner. Let's do 6√2 times the -3. That'd be -18√2. Okay? Let's do last. -3 times -4 is a +12. The denominator. Here's what we get. 6√2 times 6√2. That becomes 6 times 6 times 2. So 72. Very good. So I'm getting 72. Now, the outers and the inners, they cancel because it's the conjugate, and that's the whole point of doing that. And then all I have left with is the 4 times the -4, which is Negative 16, right? Okay, so now I'm in better shape because I no longer have a square root on the bottom. So let's gather up all my terms on the top there. Looks like I'm going to get negative 32 root 2 and then a negative 18 root 2. And then I have a 96 and 12. So 96 plus 12, that's 108. Minus, let's see here, what's 32 and negative 18? Yep, and, minus 50 root 2's. All divided by 72 minus 16? 56, right? All right, getting better. Now, can that cancel anymore? Can we simplify that? Yeah, we sure can. Factor out a 2, right? Okay, so that's going to give me 54 minus 25 root 2 all over 28. And that right there is our exact value for the tangent of alpha plus beta. Okay, here's the utri, here's the setup. Giving you cosine of alpha is 8/17. Alpha's in quadrant 4. Sine of beta is negative 1/2. Beta is in quadrant 3. What is the tangent of alpha plus beta? Please do the entire process. Please draw the pictures, alpha and beta. Please find the missing sides. Please apply the formula, and then please simplify. You should take about 5-10 minutes. Okay, so do you agree that it's challenging, these problems can be challenging on the back end if you don't do the computation right? Because we spent about 10 minutes on this, and we got about 3 or 4 different answers. So I want to go over this with you and make sure you have it. So hopefully everybody has the setup correctly. You've drawn this picture, right? And the highlighted ones are the missing ones that you should have found by Pythagorean theorem. Is that true? Mm-hmm. Okay, so here we go. So let's do this all.
Your microphone's on.
Yeah, I know. It's supposed to be on.
Hello.
It's supposed to be on. Okay. All right, here we go. So what did you guys get for the tangent of alpha? Let's do it together.
Some random.
No, help me out. Tangent alpha, look at the alpha picture. What's it going to be? Yes, very good. So negative 15 over 8 plus, let's see here, what's the tangent of beta? So isn't that positive 1 over root 3? All divided by 1 minus negative 15 over 8 times 1 over root 3. Okay, who got this far? Raise your hands. Who got this far? All right, so about most of you got that far. Okay, good. So I need to rationalize some stuff and make common denominators. So I'm going to have negative 15 over 8 plus, this is going to be a root 3 over 3, right? All divided by 1 plus, this is going to be 15 over 8 root 3. So I simplified a little bit. Now I need to rationalize and get a common denominator. So this piece is going to need what over what? What's 3 times 8? The common denominator is going to be what? 24. So what does that piece need? It needs a 3 over 3. Very good. What does this piece need? It needs an 8 over an 8. Good. So that's going to give me, on the top, negative 45 plus 8 root 3, all divided by the common denominator, 24, divided by, yeah, right, yeah. Okay, divided by, this is going to give me, if I rationalize the denominator here, I need a root 3 over a root 3. So it's going to give me 1 plus, let's see here, 15 root 3, all divided by 8 times 3, which is what, 24. Okay?
Yeah.
Good.
Oh, I did 1 minus.
So negative 45 plus 8 root 3 all over 24. All divided by, this piece needs a what over what? 24 over 24. Good, okay. So it's going to be 24 plus a 15 root 3 all divided by a 24. Who got this far? Hands up. Okay, now we're down to 3 people who got that far. Good. Okay, notice, right, if you have a fraction over a fraction, fraction over a fraction, and all good? You good?
Yeah, that's what we had.
All right.
I got that, but my bottom was 24 minus 15 root 3, not
You gotta watch that sign, right? Okay. So I'm gonna rewrite it like this. I'm gonna write it as 8 root 3 minus 45, all divided by 15 root 3 plus 24. So far, so good? Sweet. Then multiply by the conjugate. What is the conjugate?
24 minus 15 root 3.
So yeah, 15 root 3 minus 24. 15 root 3 minus 24. After all, that is a fancy 1. We are allowed to do that without changing the value of our term.
Wait, when did you get this negative 24 piece?
I just, what? Where? That's the conjugate. That's the conjugate.
Conjugate, so you can rationalize the denominator.
All right, here we go. First, what's 8 times 15 times 3? Help me out, help me out.
Wait, can you move up a little bit?
Yeah, move up a little, sure. Good, yep, I got 360. Okay, there's my first. Let's do my outer. What's 8 root 3 times negative 24? What'd you get? 8 root 3 times negative 24. No, that's going to be negative 192 root 3s. Okay? Inner. Let's do 45, negative 45 times 15 root 3. What do you get? Negative 675 root 3. Very good. And then finally, negative 45 times negative 24. What's that? Plus 1080. Very good. All right. On the denominator. 15 root 3 times 15 root 3. Gives you 15 times 15 times 3. What's that going to be? No. 675. And then the outers and the inners cancel for FOIL. So I have the last term. So I've got negative 24 times positive 24 is minus 576. All right, keep going. Let's see here. I'm going to have 360 and 1080. What's that? 1440. Okay, minus, let's see here, negative 192 and a negative 675 is a negative 867 root 3, all divided by 675 minus 576 is a grand total of 99, right? You can divide each term by 3, giving you 480 minus 289 root 3, all divided by 33, which I believe, whoa, Jody and a few other people up there got correct. Okay, who else got that right? Hands up. Let the record show there are 1, 2, 3, 4, 5, 6, 7 of my amazing pre-calculus students who got that answer right. Okay. All right, this one's not so bad. So we're going to verify the identity using sum and difference formulas for tangent. So the tangent of x plus pi, show that that's just equal to the tangent of x. All right, so what side do you want to start on, left or right? Yep, let's go left. So we're going to not distribute, all right? That's not what that means, to distribute that tangent. Rather, we actually have a formula for that, and that's going to be the tangent of x plus the tangent of pi, all divided by 1 minus the tangent of x times the tangent of pi. All right, so we need to figure out, we can't do anything with the tangent of x, but the tangent of pi we can do something with. So here's our unit circle. Pi is over here. That is the point negative 1 comma 0. Negative 1 is for cosine. 0 is for sine. So therefore, ladies and gentlemen, what's the tangent of pi? If the tangent is what over what? 0 over negative 1. So what is that value? What's the tangent of pi, everybody? 0. So this becomes the tangent of x plus 0 over 1 minus who cares, because 0 times whatever is 0. So therefore, what am I left with? What's tangent x plus 0? Tangent of x divided by the number 1, of course, is nothing more than the tangent of x. WC stands for who cares, because it's 0 times whatever, right? What do you guys think about that one? How would you rate that one? Green circle? Okay. All right. So we have about 11 minutes left. Ladies and gentlemen, try this one on your own. Do what's the tangent of x minus pi over 4? Show that that's equal to this. The tangent of x minus 1 all over the tangent of x plus 1. Ready, set, go. Tiff, go for it.
So I use this sum and difference formula.
Okay.
For tangent.
Yep.
And so I got tangent of x minus tangent of pi over 4 over 1 minus tangent of x tangent pi over 4.
1 minus tangent of x, tangent of pi over 4. Good. Awesome first step. Then what?
Tangent of pi over 4 equals 1.
Oh, wait. Should be 1 plus, right? Okay. Yeah. Then what?
Tangent of pi over 4 is just 1. So
Oh, yeah. So all of this stuff has a value of 1, right? So that gives you what? Tangent of x minus 1 all over.
1 plus tangent of x, which is the same thing as tangent.
Yeah, because that's a value of 1. So 1 plus the tangent of x which is just tangent of x minus 1 over tangent of x plus 1, which is exactly what we were supposed to show